Hello everybody. In today's lesson, lesson 1.6, we're going to be working with an algebra concept where we add in any order. Okay. And some materials we'll need for today's lesson are two different color connecting cubes and a red and a blue crayon or color pencils. Alright, so listen to the following problem and then we're going to model it. Okay, and remember you can pause the video so that you can set it up yourself prior to me telling you what to do or what I would do. Use your connecting cubes to show 2 plus 3. And then we're going to show 3 plus 2. Okay. So So 2 plus 3. Okay, and what is 2 plus 3? Well, 2 plus 3 is 2. 3, 4, 5. Okay. Now how can we show 3 plus 2? Well, we can just flip it around. Okay, you can just flip your connecting cubes over. And now we have 3 plus 2. And what does 3 plus 2 equal? 3, 4, 5. Okay. So how are the answers the same? Or why are the answers the same? Because the problem is set up differently. It goes 2 plus 3, and in this one we did 3 plus 2. Why did they both give us 5? Well, did we change the numbers being added? No, they're still, the parts are still 3 and 2, right? 3 and 2. It doesn't matter which order you put them in. Okay, I'm going to teach you a very special word, and I want you to see if you can say this word. What we're just showing right now is a very important math concept called commutative property. Can you say commutative? And that basically means that the order in which you add two addends will not change the sum. Okay, and that's what we're going to be practicing today. Okay, so let's go to page 34. Okay, so in this one, we see that they have one red cube plus 3 more blue cubes, giving them a sum of 4. So the addends, the two numbers being added, are 1 and 3. But now look at this one. Now we have 3 blue plus 1 red cube equals 4. So the order of the addends here is 1 plus 3, and here it's 3 plus 1. It doesn't change the sum. Okay. So if the two numbers you're adding are the same, you'll still get the same sum. So why is that important? Well, here we start with 1 and we have to add 3 more. We count on 3 more. But if we think of it differently and say, oh, well, why don't I start with 3 and count on 1? That's a lot easier to do. 3, 4, as opposed to 1, 2, 3, 4. Okay? All right. So now use your cubes, and we're going to color these cubes, okay? Color to match the problem. 2 plus 3. Okay, well, I have 2 plus 3 from our warm-up problem. 2 plus 3. So really doesn't matter which color you choose to start with. You just have to model it. So here's 2. I'm drawing 2 red, and then I'm going to color the other 3 blue. Okay, so 2 plus 3, right? 2 red, 3 blue. What is the total? What's the sum? Okay, the sum is 2, 3, 4, 5. Okay, so the 2 addends are 2 and 3, and my sum is 5. All right, change the order of the addends and color to match. Write the addition sentence. So now, let's flip it. Okay, so now we're going to have 3 blue, and 2 red. So now what is my math problem? Okay, well, I'm still using the same addends. The order has changed though. Now I'm going to start with 3, and I'm going to add 2 more to it. What's the sum? Well, here 2 and 3 gave me 5. I'm using the same addends, so I'm still going to get 5. And I can prove that by counting, right? 3, 4, 5. Okay, so 2 plus 4. Okay, so here's 2 plus 4. So I'm going to color 2 of mine red. And again, you could start with blue if you wanted to instead. But I'm going to do 2 red and 4 blue. What I'm saying is it could have been 4 red and 2 blue. Okay, the color scheme doesn't matter. You just have to show 2 of one color and 4 of the other color. All right, and then I have 4 blue. So what's the sum? 2 and count on, right? 2, count on. 3, 4, 5, 6. So the sum of that problem is 6. Now flip it and write the answer, or the sum. So now we have 4 blue first, and we're going to add 2 red. So what's our answer? 4, right? We started with 4. Add 2 more. Add the 2 red cubes. Give us how many connecting cubes? Well, here the sum of 2 and 4 was 6. Here I'm still using 4 and 2. It's just the 4 comes first, so my sum still has to be 6. I can prove that by, okay, so where there was 4 blue, count on. 4, 5, 6. All right, let's try this one. Okay, so 4 plus 1. So I have 4 reds and 1 blue. And 4 plus 1 is what? 4, 5. Okay. If I flip it, that's what commutative property basic means, is change the order. Change the order. I get 1 blue, and I'm going to add 4 red. So 1 plus 4 equals what? What sum? Again, here we had 4 and 1. Here we have the same addends, but in different order. Okay, commutative property. Same addends, different order, doesn't change the sum. 5. Okay, let's go on to page 35. Okay, so look for structure. Use connecting cubes, two different colored connecting cubes, to write the sum. Remember, sum means the answer to an addition problem. Circle the addition sentences in each row that have the same addends in a different order. Okay, so let's see. Let's see if we have this one somewhere else. So we have 1 plus 2. Okay, 1 plus 2. Let's do 1 plus 3. So in other words, let's model all three problems. Okay, that's 1 plus 2, 1 plus 3, and we want 2 plus 1 for the last one. Okay, all right. So this answer is 1, count forward 2 more, 1, 2, 3. This one, we start at 1, and we're going to count on 3. 1, 2, 3, 4. This one, we're going to start at 2. Okay, 2 and add on 1 gives us 3. Okay, so now, which ones have the same addends but in a different order? 1, 2. 1, 3, 2, 1. Well, these two do, correct? And that makes sense because the sum is the same. So let's circle 1 plus 2 and 2 plus 1. All right, now let's show 1 plus 5. Okay, so there's 1 plus 5. 4 plus 2. Okay, 4 plus 2. And let's do 2 plus 4. Okay, so I'm going to put that one down there. All right, so this one, let's start with this. 1 and add 5 more. 1, 2, 3, 4, 5, 6. So 1 plus 5 has a sum of 6. 4 plus 2, 4, 5, 6. Okay, this one, 2, 3, 4, 5, 6. Okay, now be careful. Okay, all of these have the same sum, but only 2 use the same addends. So which of your sets match? Okay, it's not this one, right? That's 1 plus 5. But that's 4 plus 2, 2 plus 4. So the same addends. So it's the last two. All right, choose addends to complete the addition sentence. Change the order. Choose addends to complete the addition sentence. Change the order. Write the numbers. So there's multiple answers for this. Okay, we just need 2 addends. When you add them together, give you 10. Okay, so can you think of 2 numbers that would give you 10? Okay, let's say I'm going to have, let's say I start with that. This right here. Okay, 1, 2, 3, 4, 5, 6. Okay, so I have 6 red connecting cubes. I need to add blues until I get to 10. Okay, so I can add one at a time if I need to. 6, that's 7, 8, 9, 10. Okay, so that's 10. So what did I add? That's 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4. Okay, so 6 plus 4 is 10. Now change the order. We'll just flip your connecting cubes over. And instead of doing 6 plus 4, it would be 4 plus 6. And we still get a sum of 10. Okay, number 7. Write 2 addition sentences that tell about the picture. Okay, well, I could start with the brown cats, right? 1, 2, 3, 4, 5 brown cats plus 1, well, that almost looks pink, huh? 1 cat is how many cats? 5, one more is 6. Now, could I have started with the 1 cat? Sure. 1 plus the 5 equals how many cats? 6. Okay. Again, you notice same addends, 5 and 1, 5 and 1, 5 and 1, but they're in different order. And they both have the same sum. Okay, page 36. Draw pictures to match the addition sentences. 2 plus 6. Okay, let's see. 2 okay, 2 plus 6. 2, 3, 4, 5, 6. 2 plus 6. 1, 2, 3, 4, 5, 6. So what's my answer? 2, 3, 4, 5, 6, 7, 8. So I have a sum of 8. Now what if we just switch the order? Okay, we still have 6 and 2, right? But they're in different order. So I'm going to draw the 6 blue first this time. Okay, so 2, 4, 6. And then I'm going to add the 2 red. Okay, so we've modeled this 6 plus 2. 6, 7, 8. Okay. It was easier, in my opinion, to count on from 6 plus 2 rather than going from 2 and adding 6 more. All right, 1 plus 5. Okay, well, 1, and then we need 5 blue. So 1, 2, 3, 4, 5. Okay, so how many do we have? What's the sum of these connecting cubes? 1, and count on 5. 1, 2, 3, 4, 5, 6. So the sum of 1 and 5 is 6. Use the same things, but in a different order. So start with the blue this time. 5. So draw 5, 3, 4, 5, and add 1 red. 5, add on 1 more, 6. Okay, same addends, different order. Gives us the same sum of 6. All right, and finally number 10. Draw lines to match the same addends in a different order. All right, well, let's look at the addends. 7 plus 3. So the same addends in a different order would be 3 plus 7. Do you see 3 plus 7 anywhere? Yeah, I see it down here too. Yes. Okay, so draw a straight line to 3 plus 7. Okay. All right, now we have 3 plus 6. So the same addends in a different order would be 6 plus 3. 6 plus 3 has a sum of 9. Connect those. Okay, and then 4 plus 6 has a sum of 10. Which problem has the same addends but in a different order? So here we have 4 first, 6 second. We'd want the 6 first and the 4 second. I see it over here. So go ahead and draw a line all the way to that one. Okay. All right, boys and girls, so that's it for lesson 1.6. Working with adding in any order. Okay, and remember we called this idea of adding in any order a very special concept known as commutative property. So until our next lesson, I will see you soon.